Hello, everyone. So this is going to be a virtual lecture that is going to replace class for Thursday, September 26th, as we have some crazy weather headed our way. So we're going to finish Module 6, and I'm going to be moving the deadline for Module 6 back to Tuesday, just so that everyone has a chance to ask questions on Tuesday in class, and you have a little bit of extra time. Um, so we can talk about any questions that you have on Tuesday. All right, so we started doing some examples in class, and I just want to continue, and then we'll talk about some new material. All right, so number 2, we have an angle, and we're naming it beta, right? This fancy B is beta, and it's an angle such that the cosecant of beta equals negative 5/4, and the tangent of beta is less than 0. We need to find the exact values of the cosine of beta and the cotangent of beta. Okay, so we did a problem similar to this in class. The one we did in class, we were told which quadrant our angle lived in, and then we were able to use that to draw our angle and then create our reference triangle. That's the triangle that you make from your terminal side to the x-axis using your reference angle. But here I'm not told which quadrant my angle beta lies in. What I'm told is that the cosecant of beta is negative 4/5. Okay, cosecant. Which ratio comes out of cosecant? Well, this is sine, but upside down. So sine would be opposite over hypotenuse. So this is hypotenuse over opposite. Okay, so I know that the hypotenuse of my triangle is 5, and the opposite is going to be negative 4. So this negative out front can go with either the 5 or the 4, but not both. And remember, we talked on Tuesday, the hypotenuse is always positive. So that negative needs to go with the 4, so our opposite side is negative 4. Now, if I'm going to draw this, I still need to figure out which quadrant I'm in. Well, to figure out which quadrant I'm in, I need to know the signs of two trig functions. And we looked at this on Tuesday, but I know the signs of sine, cosine, and tangent in all 4 of my quadrants. But I don't have sine, cosine, or tangent. I've got cosecant. Well, if cosecant is negative 5/4, and I know that my hypotenuse is 5 and my opposite is negative 4, then I know what the sine of beta is, right? The sine of beta is going to be the reciprocal of that. It's going to be negative 4, my opposite side, over my hypotenuse of 5. So I know that my sine is negative. And I'm also told that tangent of my angle is also negative. So I know that sine and tangent are both negative in the quadrant that I'm in. So if sine and tangent are both negative, which quadrant do I have to be in? Yep, you got it right here. It is quadrant 4 because that's the only place where both sine and tangent are negative in the same quadrant. So I know that my terminal side is going to be down here somewhere in quadrant 4. And so I know that this whole big thing is going to be what beta looks like. It might rotate slightly differently than that, but I'm going to use the positively rotating one because our brains like that better. And so from here, in order to find the trig functions of this giant angle, remember we have to use our reference angle. So here is my beta ref, and I'm going to drop my terminal side down to my x-axis to make my reference triangle. And this is the triangle that I'm going to use to kind of solve this problem. And beta ref, my reference angle here, is going to be my point of reference. So I know that my opposite side is negative 4 and my hypotenuse is positive 5. Here's the hypotenuse of my triangle, so that's +5. The opposite side from beta ref is over here. This one's going to be -4. Now, this -4, that is on a side that goes up and down, right? It's on a side where we would have a y value, and y is negative in quadrant 4, so that makes sense. This should be negative. Now, I need to figure out what this side is, so you're going to do the Pythagorean theorem. You will do a squared plus b squared equals c squared, and we'll solve that out. You've done this so many times, so I'm just going to kind of rocket through it. You'll subtract 16 from both sides, and you'll get that a squared equals 9. Now that we are on the Cartesian plane here, we have to be more careful. And when we take the square root of both sides, a could be positive or -3. We have to remember our plus and minus here. So now we have to decide whether this side is +3 or -3. So this side is along the x-axis. So is x positive or negative over here? Yep, that's where x is positive. So that side is going to be +3. Now I have my reference triangle complete, and I can find the values of cosine of beta and cotangent of beta. Cosine is adjacent over hypotenuse. So here my adjacent side, using my beta reference here, my adjacent side is 3, the hypotenuse is 5. And the cotangent, this is tangent upside down, so this is adjacent over opposite. My adjacent side is 3, and my opposite side is -4. So the cotangent of beta is -3/4. And we have solved the problem. So now you just have to be careful. We're doing the same things that we've been doing. We've done this before back in module 4 or 5. I'm trying to think. I think it was 4, right? We've been solving triangles. No, it was 5 because we had the trig functions. So we've been doing this for a while, but now we have to be careful with your pluses and minuses and which quadrant we're in. That's just the extra bit that we added here. All right, now to continue on, we have a couple of special triangles to introduce to you. We actually solved these in module 4, but I didn't make a big deal about it, and I didn't really point out that these were going to be special. So I'm going to try to make these reasonably accurate. Okay, so 45, 45, 90, these refer to the angles in the triangle. So I've got two 45-degree angles and a 90-degree angle in this triangle, and a 30, 60, 90 triangle has a 30-degree angle, a 60-degree angle, and this 90-degree angle. Now, these are going to be special for us, and we just kind of have to start memorizing some of the ratios in here. So in a 45, 45, 90, the sides opposite these equal angles will also be equal. So to start out, I'm going to make those legs be the same length. And for ease of working with numbers, I'm going to say each of those sides has length of 1. And then if these sides both have a length of 1, you can do the Pythagorean theorem. We actually did that in module 4, and you will find that the hypotenuse is square root of 2. And then in the 30, 60, 90 triangle, the angle opposite the 30-degree angle, the side opposite the 30-degree angle is half the length of the hypotenuse. So to make these numbers easy to work with, I'm going to call the side opposite the 30-degree angle have a length of 1, and I'm going to make the hypotenuse have a length of 2, so that the side opposite the 30-degree angle is half of the hypotenuse. And then now that we have two sides, I can use the Pythagorean theorem to solve for this missing third side. Again, we did this in module 4, and we found that that side was √3. So these are going to be special triangles for us. We're going to be using these for the remainder of this module, and they're going to help us create something called a unit circle that we are going to know and love and continue to use for the remainder of this term. Okay, So now that we have those triangles, we'll use those in a second. Um, one thing to notice, this is sort of a question, but something to notice is that the trig functions for any angle with the same reference angle will have the same value but different signs. Okay, so what I mean by that, I have an example here. I've got a 60-degree angle in standard position, right? That's 60 degrees. I have a 120-degree angle here, again in standard position. That starts in standard position and goes here. I've got a 240-degree angle down here that starts here and goes around. And I've got a 300-degree angle down here that starts here and goes all the way around that way. So all of these angles have the same reference angle. So to see that, I'm going to mark the reference angles for each of these. This is my reference angle here. This is my reference angle here. This is my reference angle in this quadrant, and here is my reference angle for 300 degrees. And you can go through and find your reference angles for each of these. You will find that your reference angles for every single one of these angles is 60 degrees. They all have the same reference angles. And so basically, when that happens, whether I'm doing the sine of 60 degrees or whether I do the sine of, let's say, 240 degrees, these two values will have the same value, the same number value, but they might differ in a sign. One of them might be positive and the other might be negative. Now, why would that be? Well, to find the sine of 60 degrees, we would make our reference triangle. So we would take our terminal side here, and we would drop an altitude down to the positive x-axis here. And here's my reference triangle. This angle down here, my reference angle is 60 degrees, which means this angle up here is 30 degrees. I have a 30, 60, 90 triangle. And again, in a 30, 60, 90 triangle, this side opposite the 30-degree angle is 1/2 of the hypotenuse, which means this other side is root 3. So what's the sine of 60 degrees? Well, it's the opposite side, root 3, over the hypotenuse of 2. Okay, great. Now, what if I wanted to find the sine value of 240 degrees? Well, 240 degrees is right here. So I would take my terminal side and drop an altitude to my x-axis, always the x-axis. And here is my reference triangle. And I'm going to use my reference angle here. And my reference angle is 60 degrees. So again, I know that this extra angle up here is 30 degrees because all three angles in a triangle have to add to 180 degrees. So this is also a 30, 60, 90 triangle. And I know that the side opposite the 30-degree angle has to be 1/2 of the hypotenuse. And that means that the side opposite the 60-degree angle is going to be root 3 right here. And notice I have the same triangle. It's oriented a little bit differently, but it is the same angle. And I'm using the same reference angle to find my trig function. But now I'm in quadrant 3. So when I put my sides in here, I just have to be careful. This side is along the negative x-axis, so that side's going to be -1. And this side is along my negative y-axis, so this side is actually -3. It's the same triangle, it's just in a different quadrant, so we have to be careful with our positives and our negatives. So the sine of 240 degrees is going to be the sine of this reference angle in here. It's going to be the opposite side, which is -root 3 over my hypotenuse of +2. Notice both 60 degrees and 440 degrees had the same reference angle of 60 degrees. And notice their sine values have the same value, but one's positive and one's negative. If you wanted to go through and find the sine values for 120 degrees and 300 degrees, you would find that they are all the square root of 3/2. But in quadrant 2, the sine of 120 degrees, I know the value is going to be the square root of 3 over 2 because it has the same reference angle as both 60 and 240 degrees. But I'm in quadrant 2, and because all students take calculus, this tells us which is positive in each quadrant. I know that in quadrant 2, sine is positive. So the sine of 120 degrees is going to be positive root 3 over 2. And I know that the sine of 300 degrees is also going to have a value of root 3 over 2. But because 300 degrees has a terminal side in quadrant 4, and cosine is the only positive trig function there, I know that the sine of 300 degrees is going to be negative there. And so this value is going to be negative root 3 over 2. They all have the same value. You just have to be careful with the sign. And all students take calculus will help you with that. Hopefully that all makes sense. And we are going to use the fact that all angles with the same reference angle have the same trig values. That's going to become important to us in just a minute when we are creating something called the unit circle. Okay, unit circle. I'm going to give you a general definition of a unit circle, and then we are going to construct something that we like to call the unit circle in trig. It's going to be a tool that we're going to use throughout the semester to find trig values quickly and easily. Okay, so a unit circle in general basically just means a circle centered at the origin, 0, 0, with a radius of 1. That's what the unit part means. Unit means 1. The radius is going to be 1. It's a circle with radius 1. And specifically, our circle is going to be centered at 0, 0. So if you remember from geometry, assume geometry is where you would see this, the equation of a circle in general is going to be x squared plus y squared equals r squared, where r is the radius of the circle. And again, this equation assumes that our circle is centered at 0, 0, so it simplifies it just a little bit. But this is an equation of a circle centered at the origin with radius r. So specifically, this is centered at 0, 0 with a radius of r. But our unit circle is centered at the origin with a radius of 1. So the equation of the unit circle specifically, again, is going to be x squared plus y squared because it's a circle, and it's going to equal our radius squared. But on the unit circle, our radius is 1. And what is 1 squared? 1 squared is just 1. So I can actually just erase that because 1 squared is just 1. So the equation of the unit circle is x squared plus y squared equals 1. Okay, so knowing that, let's say I have a point, the ordered pair 1/2 y. It's in quadrant 1, and it lies on the unit circle. Again, unit circle, it's over here. Pretend that's a perfect circle. And this thing has a radius of 1. So I'm going to go out in each direction from there, 1 unit. This is my unit circle. And I know that this point 1/2, right? X equals 1/2 is right here. And y is going to be whatever this y value is. And I need to figure out what y is so that this is a point on the unit circle. Okay. Well, because this point's on the unit circle, this x and this y need to satisfy this equation. If they didn't satisfy that equation, they would not be on this circle. So in order to be on the circle, I need x squared plus y squared to be 1. My x is 1/2. I don't know what y is, so I'm going to leave it y, and I know that has to equal 1. This is now an equation I can solve. I can go ahead and I can square this. 1/2 times 1/2 is 1/4. plus y squared equals 1. Now to solve for y, what would we do from here? Yep, we would subtract that 1/4 from both sides. And then I'm going to move this up here. So I would get y squared equals 1 minus 1/4. That's going to be 3/4. You can get a common denominator there. 4/4 minus 1/4 is 3/4. And so that means that y has to be the square root of both of those. And so I know that y has to be, and again, I took a square root. Don't forget your plus and minus. I know that y has to be plus or minus the square root of 3/4. I can apply that root to top and bottom because you can distribute across division with roots. So that's the square root of 3 over the square root of 4, which is plus or minus the square root of 3 over 2, because the square root of 4 is just 2. Now the question is it positive or is it negative? And the answer is right here. I know that this point has to be in quadrant 1. In quadrant 1, both x and y are positive. So I know that I need the positive root 3 over 2 value because quadrant 1. Say positive because quadrant 1. So that has to be the y value in order for this to be on the unit circle. Okay, so I want you to try this one. So we have another point. It's now x comma negative 8/17. This point is in quadrant 3 and it's on the unit circle. So again, we have our unit circle. Pretend that's a circle. We are in quadrant 3 and I know that y is negative 8/17. So I don't know, we're about halfway-ish, right? Negative 8/17 is here somewhere. And so I know that we're looking for this point on the unit circle here, and I have to figure out what that x value is. I want you to pause the video. I want you to use what we just did, and I want you to see if you can figure out what x is. All right, hopefully you've had a chance to work that. And I know that y is negative 8/17, and I'm trying to find the x value that goes with it in order for this point to be on the unit circle. Again, to be on the unit circle, this x and this y value have to satisfy the equation x squared plus y squared equals 1. I don't know what x squared is. I don't know what x is. I'm just going to leave it x. But I know what y is. It's negative 8/17. So I know that x, whatever it is, squared plus negative 8/17 squared has to equal 1. So from here, I just have to solve this. Again, I'm going to square this thing, and you're going to get 64 over, go brain go, 289. And that's got to equal 1. I got to get to x. So I'm going to subtract this beautiful 64 over 289 from both sides. And we're going to move up here. So that means x squared has to be 1 minus 64 over 289. I'm going to get a common denominator. I'm going to turn 1 into 289 over 289, and I'm going to subtract 64 over 289 from it. When I do that subtraction, I'm going to get 225, assuming I can do mental math, over 289. And then how do we solve this for x? Yep, you're right. Take the square root. And so that means x is going to be plus or minus, don't forget it, the square root of 225 over the square root of 289. You are going to use your handy dandy TI-30X2S, and you'll find that the square root of 225 is 15, and the square root of 289 is 17. So that means x is going to be either positive 15/17 or negative 15/17. Which is it? The answer is right here. In order to be in quadrant 3, my x values are negative, which means I need to take the negative one. X is going to be negative 15/17 in order for this ordered pair to be on the unit circle in quadrant 3. Okay, cool. So that's what the unit circle is, right? It's a circle centered at the origin with a radius of 1. And we are going to use it in an interesting way to help us find trig functions of very special angles. And our special angles are all going to be multiples of 30-degree angles, 60-degree angles, or 45-degree angles. So that's where these nice special triangles are going to come into play. And the way that we're going to do this is we're going to use these triangles and our unit circle to help us. And so on this unit circle, I've got all of our special angles. So 30 degrees or pi over 6 radians, 45 degrees or pi over 4 radians, 60 degrees or pi over 3 radians, 120 degrees or 2 pi over 3 radians, 135 degrees or 3 pi over 4 radians, 150 degrees or 5 pi over 6 radians, 210 degrees, that's 7 pi over 6. 225 degrees is 5 pi over 4. 240 degrees is 4 pi over 3. 300 degrees is 5 pi over 3. 315 is 7 pi over 4. And 330 degrees is 11 pi over 6 radians. These are our special angles. These are all of the multiples of 30, 45, and 60 degrees between 0 and 360. And we also have our landmark angles here too, 90, 180 degrees, 270 degrees, and 360 degrees here. So, because those landmarks are also multiples of 30, 45, and 60 degrees as well. Okay, so the way that we're going to do this is we're basically going to figure out what the sine and cosine values for each of these angles is, and we're going to write it as an ordered pair. And you'll see why we'll be able to do that in a minute. So to do that, let's start with 30 degrees. To find the sine and cosine of 30 degrees, I would take this a point on my terminal side and drop it down to the positive x-axis. And notice 30 degrees in standard position is this angle. And notice it's the same as my reference angle. And I'm going to use my reference angle to find the trig functions of this angle. And my reference angle is the same as my my angle in standard position in quadrant 1. So I know that my reference angle here is also 30 degrees. This is a 30, 60, 90 triangle. So I know that the side opposite the 30-degree angle is half the hypotenuse. But notice if I put a 1 here and a 2 here, this side is a radius in my circle. It can't be 2 because this is the unit circle. And on the unit circle, the length of my hypotenuse, my radius, should be 1. It has a radius of 1. So this can't be right. So in order to use these special triangles on the unit circle the way that I want to, we have to scale them down. I need to make sure that my hypotenuse is 1. So if I take my 30, 60, 90 triangle, use your imagination and pretend that's a pretty 30, 60, 90 triangle. So this is a 30-degree angle. This is a 60-degree angle. I want my hypotenuse to be 1. For here it was 2. So if I'm going from this triangle to this one, I'm cutting it in half, right? And if what I do to one side, I have to do to the others. So to get this side, I'm going to take root 3 over 2, and I'm going to divide it by 2 because this angle is half the size of the other one. And to get this side on the bottom, I'm going to take this 1 and I'm going to cut it in half because we're scaling this down and everything is cut in half. So now this is my scaled down 30-degree angle. Notice the side opposite the 30-degree angle is still half the hypotenuse, but instead of using 1 and 2, I'm going to use 1/2 and 1. Now this triangle fits nicely into my unit circle, and I know that the square root of 3 over 2 goes down here. Now, what's the cosine of pi over 6, this 30-degree angle? Well, the cosine of this angle is going to be, we're going to use our reference angle here to do it. It should be adjacent over hypotenuse. My adjacent side here is the square root of 3 over 2. And my hypotenuse is 1. That means that the cosine of this 30-degree angle, or pi over 6, is the square root of 3 over 2. And the sine of this angle, pi over 6, the sine, I'm going to still use this reference angle, it's going to be opposite, which is 1/2, over the hypotenuse, which is 1. That means that the sine of pi over 6 is 1/2. Notice my x coordinate here, the length of my x on this, is root 3 over 2. That's the cosine of my angle. And notice my y value here is 1/2, which was the sine of pi over 6. This is going to be the ordered pair that lies right here on the unit circle. It is root 3 over 2, 1/2. And notice that the root 3 over 2, this was the cosine of this angle, and 1/2 was the sine of this angle. Okay, so this ordered pair, root 3 over 2, 1/2, this is the point on the unit circle that coincides with where the terminal side of a 30-degree angle or a pi over 6 angle hits the unit circle. And notice that our x value coincides with our cosine value, our y value coincides with our sine value. That's not a fluke, that's a thing. Okay, so now what if we do this all over again, but for the next angle? What if I use a 45-degree angle here? So I'm going to do the same thing, and I want this point right here. So I'm going to drop an altitude down to my x-axis, and this is my angle theta, which is 45 degrees, also my reference angle. This is a 45, 45, 90 triangle. And again, I would really like to put this 45, 45, 90 triangle in here, but again, my hypotenuse is a radius of the circle, which means I need my hypotenuse to be 1. This hypotenuse is not 1, so I need to scale it down. Okay, again, pretend this is a nice 45, 45, 90 triangle. Use your imagination for me. And we need to scale this down. I need my hypotenuse to be 1. So how did I go from this side being root 2 to this side being 1? I had to divide the square root of 2. So I'm going to scale everything down by dividing by the square root of 2. So that means that this side here is going to be 1, but divided by the square root of 2. And this side is also going to be 1, but divided by the square root of 2 to scale it down. Now, when we are on the unit circle, we are going to go ahead and rationalize these. I mentioned this briefly in class. You won't have to rationalize for me, but when we are on the unit circle, everything's going to be rationalized. So I'm going to go ahead and take a second to rationalize this. And when you multiply across, you get the square root of 2 over 2. These are the side lengths rationalized without having a radical in the denominator. So those are going to be the sides for my 45, 45, 90 triangle scaled down. So I'm going to have a hypotenuse 1. I'm going to have this side as square root of 2 over 2. This side as square root of 2 over 2. And notice this ordered pair here is the square, my x value is the square root of 2 over 2. And my y value here is the square root of 2 over 2 as well. This is the ordered pair of this point right here. And again, notice that the cosine of 45 degrees, this angle is going to be the adjacent side, which is down here, my square root of 2 over 2. over the hypotenuse of 1. The cosine value is root 2 over 2. That's the same as my x value. And the sine value of 45 degrees is opposite over hypotenuse, which is root 2 over 2. That's my opposite over 1. My sine value is root 2 over 2, which coincides with my y value, because y is your opposite side here. Okay, so you could continue to do this, and you can put your triangles in here. I'll do 60 degrees again, just so that you can see it, because this is something that we're going to be using a lot. So if I want the, oh, sorry, here we go. If I want the ordered pair here at 60 degrees, I'm going to drop my altitude down. This reference angle here is 60. That's a 60 degrees. This is a 30, 60, 90 triangle. My 30 degrees is up here. The 30-degree angle is half the hypotenuse, and my hypotenuse is 1. And that means this side over here is the root 3 over 2. And that means that to get this ordered pair, my x value is 1/2. And my y value is root 3 over 2. And again, notice that the cosine of 60 degrees adjacent over hypotenuse is the adjacent side is down here, your x, your 1/2, and your hypotenuse is 1. The cosine of 60 degrees is 1/2, which coincides with your x value. And the sine of 60 degrees would be opposite, which is root 3 over 2 over the hypotenuse of 1. The sine of 60 degrees is root 3 over 2, which coincides with the y value. So hopefully you're starting to see the pattern here. This is going to be a very handy tool for us, because all of these ordered pairs are going to be a quick visual. Any ordered pair on the unit circle is going to be the cosine of the angle whose terminal side intersects at that point, and your y value is going to be the sine of the angle whose terminal side goes through that point. So this is how we find the sine and cosine of any angle on this unit circle. We're just going to look at the ordered pair, and it's going to tell us what the sine and the cosine values are. And for the rest of these, we're going to kind of go a little bit quicker here. This point here has an x value of 0 and a y value of 1. It's harder to draw a triangle here because it's going to be kind of a weirdo flat triangle. And so we're just going to have to kind of hit the I believe button there. This side over here, 120 degrees. Again, this has a reference angle of 60 degrees. And so this is a 30-degree angle up here. And so this is a 30, 60, 90 triangle. The side opposite the 30-degree angle is half the hypotenuse. The hypotenuse is 1. And that means this side over here across from the 60-degree angle is root 3 over 2. And since I'm in quadrant 2, my x value is negative. My y value is positive. My ordered pair here is negative 1/2 root 3 over 2. And so that means that the cosine of 120 degrees is going to be negative 1/2, and the sine of 120 degrees is going to be root 3 over 2. And something else to notice here, we talked about this a little earlier. 120 degrees and 60 degrees had the same reference angle of 60 degrees. So their sine and cosine values are the same, but could possibly differ by a sign, positive or negative. Look at their ordered pairs. They're the same. You just have to adjust the x's and y's to be positive or negative. That's going to be a thing. Notice that 135, it's a reflection of 45. That these two are going to have the same reference angle, which means the ordered pair at 135 is going to match the ordered pair at 45 degrees. So I know this is going to be root 2 over 2, root 2 over 2. But in quadrant 2, my x values are negative, so I'm going to make x negative there. 150 degrees, this is a reflection of 30 degrees. It has a 30-degree reference angle. It's going to have the same ordered pair, root 3 over 2, 1/2. And again, its x value is going to be negative because quadrant 2. And I can keep going. This ordered pair on my unit circle, I have to go to the left one, so that's going to be an x value of -1, and my y value is 0. I don't go up or down at all. All right, 210 degrees. This is a reflection of 150 degrees. These guys have the same reference angle, which again is 30 degrees. It's all going to come back here. So this has the same ordered pair as its reference angle of 30 degrees. Root 3 over 2, 1/2. Except in quadrant 3, I have to adjust for positives and negatives. In quadrant 3, x is negative and y is negative. So I have to make both of these guys negative. And this got a little hard to see. I'm going to try to put that negative so it's a little more obvious there. There we go. And 225 degrees. This is a reflection of 135 degrees. It has the same reference angle, and then it has the reference angle of 45 degrees. Those ordered pairs will match, root 2 over 2, root 2 over 2, but both x and y are negative in quadrant 3. And this 240 degrees, that is a reflection of 120 degrees, which is a reflection of our 60 degrees. They all have the same reference angle of 60 degrees. So my ordered pair is going to match my 60-degree angle there, except in quadrant 3, they're both negative. And this ordered pair down here is going to have an x value of 0, and I have to come down 1, so this is going to have a y value of -1. 300 degrees, this is a reflection of 60 degrees. It has a 60-degree reference angle, so its ordered pair is going to match the 60-degree ordered pair. 1/2 root 3 over 2, except in quadrant 4, I have to be careful. X is positive, y is negative down here, so I have to make my y values negative here. 315 degrees, this is a reflection of 45 degrees, so it has the same reference angle as that one, and therefore the same ordered pair. And again, y is negative here in quadrant 4. And 330 is a reflection of 30 degrees, so it has a 30-degree reference angle, and its ordered pair will be the same as the ordered pair at 30 degrees, just make y negative. And the last one is this 0 and 360 degrees. And again, we're going to go over 1, and our y value is 0. This, my friends, is called the unit circle. This is going to be something that you have to know and love and practice. You will not be given a completed unit circle on any of your exams this semester. You will be given a blank unit circle on pretty much all of your exams from here on out, but that means you will have to fill it in. That means you'll fill in the angles and you'll fill in the ordered pairs that go with them. So this feels like a lot to memorize, but it all comes down to these two special triangles and where they go, or you just need to memorize this first quadrant. You need to know the ordered pairs for pi over 3, pi over 4, and pi over 6. Everything else is a reflection of those, right? They have the same reference angle, which means it's the same ordered pair, and you just have to adjust the pluses and minuses. So you're going to have to practice this over and over and over again until you can get this in your brain solidly. But once you have everything in here, this is an amazing tool. The ordered pairs here are going to represent the cosine value of your angle and the sine value of your angle right away. So I can look at this, and what if I asked you for the sine of 11 pi over 6? Well, you would say, okay, well, my angle is 11 pi over 6. So I would go to my unit circle and I would find the angle 11 pi over 6. And 11 pi over 6 is right here. And the sine value is the y value in my ordered pair. So I'm going to go to the ordered pair with 11 pi over 6, and I'm going to look at its y value. This tells me that the sine of 11 pi over 6 is negative 1/2. I can just look at the unit circle and tell you that the sine of 11 pi over 6 is negative 1/2. I didn't have to plot this in standard position and find the reference angle and figure out what the reference triangle was and fill in my special triangles and do opposite over hypotenuse. I could just look on this unit circle and grab the value. There's a lot of information readily available to you in this unit circle. Okay, so now that we have this, let's practice using it. So we are asked to find the terminal point on the unit circle determined by 5 pi over 6. That's just asking me what's the ordered pair at 5 pi over 6. And you're going to have to find 5 pi over 6 on here. Now, than 1 pi, right? Because 1 pi is here, so we don't quite rotate all the way to 1 pi. So everything up here is smaller than 1 pi. 5 pi over 6 is a little bit smaller than 1 pi because 1 pi would be 6 pi over 6. So I knew it was in quadrant 2. And so that can help you find these a little bit better. Everything here in quadrant 3 is, oops, that's just ends here. In quadrant 3, these are going to be a little bit bigger than 1 pi. Right, so everything down here is going to be slightly bigger than 1. 7 pi over 6. That's 7 over 6 pi. That's a little bit bigger than 6 pi over 6, which would be 1 pi. Right, 4 pi over 3, that's a little bit bigger than 1 pi because 1 pi would be 3 pi over 3s. And then everything here in quadrant 4, this is going to be a bit smaller than 2 pi because we're not quite at 2 pi. So 11 pi over 6, that's slightly smaller than 2 pi's because 2 pi would be 12 pi over 6. It's a little bit smaller than 2 pi. 7 pi over 4, it's a little bit smaller than 2 pi because 2 pi would be 8 pi over 4. So that can kind of help you find things a little bit faster. So 5 pi over 6, this is a little bit smaller than 1 pi. So I'm going to look right before pi, and I'm here in quadrant 2. Here's 5 pi over 6, and its terminal point, right, its ordered pair here is negative root 3 over 2, 1/2. And that's all they're asking for. And now it wants me to find the cosine of 3 pi over 4. So I have to find 3 pi over 4 and look at the cosine is your x value on your unit circle. So I'm going to go to 3 pi over 4 and find the x coordinate of its ordered pair. Now 3 pi over 4, that's a little bit smaller than 1 pi, right? 3/4 is a little bit smaller than 1. So again, I'm going to look here in quadrant 2, and here's 3 pi over 4. I'm looking for the cosine, which is the x coordinate. The x coordinate here is negative root 2 over 2. So the answer here is negative root 2 over 2. I can just look at it and grab it. So I want you to take a minute and try to grab these 3 values from your unit circle. I'm going to go ahead and give you a second to do that. Pause the video and come back when you're ready. All right, hopefully you've had a chance to work these. If I want the exact value of the tangent, 4 pi over 3. Okay, 4 pi over 3. I know that 4 pi over 3, that's a little bit bigger than 3 pi over 3. So this is bigger than 1. I'm going to be here in quadrant 3. and I need the tangent value, but this is cosine and this is sine. How would I get the tangent value? Well, let's go back. I don't think I have it filled in here because I didn't have the completed notes here. Way back in our notes here, we said that if you had an ordered pair, XY, on the terminal side of your angle theta, then we could find right, we had X and Y and R here, where R was again, we called it R. It's actually going to be the radius of a circle that contains that. And we said that the sine of your angle in standard position was Y over R. The cosine of your angle in standard position was X over R. And the tangent of your angle in standard position was Y over X. These are still going to be in play here on the unit circle, but on the unit circle, our R value is just 1. So on the unit circle, that's why the sine value is just Y. It's Y over 1. That's why the cosine value is just X. It's X over 1. And to find our tangent value, we would do the Y coordinate divided by our X coordinate. So I'm going to add that to our unit circle down here, and I'm going to make a note to myself. And I'm going to say, okay, self, the tangent of theta is Y over X. I know that sine is my Y value, cosine is my X value, tangent is going to be Y divided by X. So if I want the tangent of 4 pi over 3, I'm going to go to 4 pi over 3, which is right here in quadrant 3. And I'm going to take its ordered pair and I'm going to do its y value divided by its x value. So I'm going to do negative root 3 over 2 divided by negative 1/2. Negative root 3 over 2 divided by negative 1/2. Just going to double check and make sure I got that right. Yep, that looks good. Now I have to figure out how to divide these. How do you divide things that look like this? Yeah, you're going to keep, change, flip. Negative root 3 over 2. I'm going to change the division and multiplication, and I'm going to flip this bottom one, and I'm going to make it negative 2 over 1. Now I'm going to multiply across. The negative times the negative turns into a positive. I'm going to get 2 root 3 over 2. Notice these 2's are going to cancel, and I'm just going to get the square root of 3. That is going to be the tangent value of 4 pi over 3. Okay, now how about the sine of pi? You're going to go to pi. That's one of our landmark points. Pi is over here at 180 degrees. And I want the sine value of pi. So if I'm looking for sine, am I going to look at the x or the y coordinate or some combination? Yep, sine is your y value. So I'm just going to take the y value of its ordered pair. The y value of pi is 0. So the sine of pi is 0. And now if I want the exact value of the tangent of pi over 2, I'm going to go to pi over 2. And if I want the tangent, I'm going to do y divided by x. So I'm going to take the y coordinate and divide by x at pi over 2. Pi over 2 is up here, and I'm doing y divided by x. That's 1 divided by 0. What's 1 divided by 0? Yeah, I can't do that. I can't divide by 0. That makes my head explode. This is undefined. Sometimes you don't get a value out. The tangent of pi over 2 is undefined. There's nothing there. There is no tangent of pi over 2. It's undefined. So some weirdo things can happen, but there's a lot of really great quick information on this unit circle. Okay. So, I wanted to do some Alex practice. I don't know if I'm going to be able to do this. I'm going to try and we'll see what happens. And we'll see if I can do this. But I'm going to have to remember my login name. Let's see. Go, Alex, go. I'm going to see if I can do this for you. Come on, Alex. Oh, what a marvelous modern era we live in. Okay, so I'm going to try to show you how to use Alex here. And so I want to work a problem from here. Review. I'm going to go up here to review, and I'm going to go to module 6. And the one that I wanted to do was this one, I think. Let me see. This one. Okay, so it wants me to, so it gives me a unit circle, and it wants me to sketch theta equals 7 pi over 6 in standard position, and then find the lengths of the legs of its reference triangle. Okay, so 7 pi over 6. So I'm going to kind of hop back and forth here. So 7 pi over 6. We know that 7 pi over 6 is a little bit bigger than 6 pi over 6. So I'm going to be right down here in standard position. So I'm going to come to Alex, and it tells me to drag to show the angle. So I'm going to start here in standard position. 7 pi over 6 is positive. So I'm going to go all the way around here, and 7 pi over 6 is a little bit further. I have to come to that point here, because I know we had a little bit of confusion about some of these hash marks. These are 30, 45, and 60 degree angles. The hash marks, they align with our special angles on the unit circle. So that's why they are the way they are. These outside hashes cut your quadrants into thirds, and the middle one cuts it into halves, right? They're either 30 or 45 degree sections. Okay, so here is my 7 pi over 6 in standard position. It's a little bit bigger than 1 pi. And it wants me to find the legs of my reference triangle. And 7 pi over 6, 7 pi over 6 is right here. There's my reference triangle. And this right here is a 30-degree angle, right? It matches this one. And we knew that when we put our triangle in here, this was a 30-degree reference angle. So the side opposite the 30-degree angles was half the hypotenuse, and this side was root 3 over 2. But in quadrant 3, this side was negative, and this side was also negative. And so we're going to put that into Alex. So I know that A is going to have a length of root 3 over 2, and B is going to have a length of 1/2. Now, when you're putting A and B in here, A and B are the lengths. They want the A and B to be positive. So even though in our ordered pair, they're both going to be negative, that's going to go here in our ordered pair P, but A and B are both going to be positive. So I know that this is going to be the square root of 3. Oops, let me see if I can fight with Alex here. Over 2. And my B value is going to be 1/2. And again, I know that these would be negative in quadrant 3. When you put your A and your B into Alex, they will be positive. And then when you go to put the coordinates of the point P, these are the coordinates of your ordered pair on the unit circle. This is where you let things go positive or negative when you need them to be positive or negative. So on our ordered pair, our x value is going to be negative. So this is going to be negative. Where's my negative? This shouldn't be, is that negative? Yeah, there we go. Okay, that was harder than it had to be. Root 3 over 2. And over here, let me find it again, negative 1/2 is the point on the unit circle. So that's what I wanted to show you here is you'll use your unit circle to help you plot these in standard position. So you'll rotate that around and then it draws in your reference triangle for you. When you fill in A and B, those are the lengths, keep them positive. In your ordered pair, you're going to make the things that are negative when they need to be. And then it wants me to use those coordinates to find the exact values. The cosine of 7 pi over 6, cosine is going to be the x coordinate of that point. So our cosine value here is going to be negative root 3 over 2. Negative root 3 over 2. The tangent of 7 pi over 6. How do we find the tangent on the unit circle again? Oh, that's right. The tangent is y divided by x. So I have to do negative 1/2 divided by negative root 3 over 2. I'm going to come back here to my scratch work here, and I'm going to do the tangent of 7 pi over 6. That's going to be negative, and it left me already, 7 pi over 6, we're here, y divided by x, negative 1/2 divided by negative root 3 over 2. There we go. Y divided by x. And again, to divide these, I'm going to keep the top. I'm going to change division to multiplication, and I'm going to flip the bottom and make it negative 2 over root 3. The negative can really go anywhere you need it to be. You'll multiply across. A negative times a negative is a positive. We will get 2 over 2 times root 3. That's a 3. And my 2's cancel, and I get 1 over root 3. For me, you won't have to rationalize. Alex is going to want you to rationalize. So we're going to go ahead and multiply by root 3 over root 3. And we're going to get the square root of 3 over 3. Again, this is just for Alex. You don't have to do that for me. So root 3 over 3, that's my tangent value. So I'm going to come back here. Oops, that should not be there. And then I'm going to come back down here. And this was positive root 3 over 3. That was my tangent value. And then my cosecant value. Cosecant, that's not on the unit circle either. How are we going to get cosecant? Well, cosecant's related to something that we do have. Cosecant is the reciprocal of sine. What would the sine of 7 pi over 6 be? Well, the sine value of 7 pi over 6 would be our y value here, negative 1/2. So that means that the cosecant is going to be the reciprocal of that. So if I take negative 1/2 and I flip it upside down, I get negative 2 over 1. That is the cosecant value. It's negative 2 over 1, or you could just write negative 2. And now we've used that coordinate to find our values. I'm going to check it. And let me come back up here and make sure, woohoo, it's correct. And this is how you're going to use these tools in ALEKS to set up the unit circle and complete that. Okay. So hopefully that helps with some of the ALEKS stuff. And again, you're just going to be practicing with that unit circle. The last couple things that we have here are going to be fighting with a couple of ideas and a little bit of notation. So the first thing is we are going to sketch both 5 pi over 6 and negative 5 pi over 6 in standard position. Okay, 5 pi over 6. That's a little bit smaller than 1 pi. I know that 1 pi would be here. 5 pi over 6 is going to be a little bit smaller than that. I'm going to be 1 pi over 6 away from pi up here. Right here is 5 pi over 6. So there is 5 pi over 6 in standard position. And I called that alpha. And we also want to sketch beta, which is negative 5 pi over 6. Negative 5 pi over 6 is going to start at the same place and rotate negatively through the same amount. And it's going to give me the reflection down here, right? Because that's what negative angles do, is it turns everything upside down. So negative 5 pi over 6 is going to be down here. Now, what are the ordered pairs here? Well, I'm going to go back up to my unit circle. And at 5 pi over 6, that's right here, I know my ordered pair is negative root 3 over 2, 1/2. So I'm going to come down here, negative root 3 over 2, 1/2 is my ordered pair there. And that means, what's the ordered pair down here going to be? Well, it's a reflection. It has the same reference angle. It's going to have the exact same values, root 3 over 2, 1/2. We just have to adjust the positives and negatives. And here in quadrant 3, x is negative, y is negative. We have to make both of them negative. So that is my ordered pair, negative 5 pi over 6. Okay, now that we have this, what's the sign of 5 pi over 6? Well, sine's my y value. So what's the y value of your ordered pair at 5 pi over 6? It's 1/2. I'm also asked for the sine value at negative 5 pi over 6. Again, sine is my y value. And at negative 5 pi over 6, my y value is negative 1/2. Same value, they can be different signs, plus and minus signs. All right, cosine of 5 pi over 6. What's the cosine of 5 pi over 6? Well, I'm going to go to 5 pi over 6, and cosine means I'm going to look at the x coordinate. What's the x coordinate at 5 pi over 6? Yep, it is negative root 3 over 2. So what's the cosine at negative 5 pi over 6? That means what's your x value at negative 5 pi over 6? Yep, it's negative root 3 over 2. Notice it's the same. It has the same sign, plus and minus, and it has the same value. So this is just something to notice here. Notice that if you take the angle and make it negative, sine of a negative angle, right, that negative 5 pi over 6, it was the negative of the sine value of the positive angle, right? It was negative 1 times the sine of 5 pi over 6. This one's negative, this one's positive. They're opposite signs, and that's because sine is an odd function, is something that we talked about a little bit in college algebra. But basically, a function is odd if you plug a negative in and the negative goes to the outside. That's what makes an odd function an odd function. So the sine of a negative angle is the negative of the sine of the positive angle. And you can kind of see that here. The sine of the negative angle was the opposite as the sine of the positive angle. Okay, and notice that the cosine of the negative angle was exactly the same as the sine of the positive angle, right? These matched. There was no difference at all between them. That negative inside made no difference. And that means that cosine is an even function. Again, we talked about that very briefly in college algebra. What that means is that if you put a negative in your function, it does absolutely nothing. And it's the same as if you put a positive in. So just something to notice. We will be looking at odd and even functions a little bit closer later on. Okay, and then the very last thing, and then I promise we will be done with module 6, are these examples here. This is sifting through notation and what this means. So if theta is 2 pi over 3, we need to find the values of each of these expressions. So if I want 2 times the cosine of theta, what I'm going to do is figure out what the cosine of 2 pi over 3 is, because that's my theta value, and then I'm going to multiply it by 2, right? That's what this is really telling me. It says take 2 and multiply it by the cosine of theta. So I'm going to take 2 and multiply by the cosine of 2 pi over 3. So what's the cosine of 2 pi over 3? Well, I'm going to come back up to my unit circle. 2 pi over 3 is a little bit smaller than 3 pi over 3. It's a little bit smaller than 1 pi. So I'm going to be up here in quadrant 2. 2 pi over 3 is here, and I'm looking for its cosine value. That's the x-coordinate. So the cosine of 2 pi over 3 is negative 1/2. So what's 2 times negative 1/2? Yep, it's negative 1. Cosine squared of our angle theta. Now, what is this asking us to do? I know it's weird because the exponent is here. The reason that we put the exponent here is because if I had written it at the end and I write cosine of theta squared, this looks confusing, especially because not everybody puts parentheses here. And if I don't put those parentheses here and I just write cosine of theta squared, this looks confusing to me. Does this mean that I'm taking the cosine of theta squared? Or does it mean that I'm taking the cosine of theta and squaring it? Those two operations are not the same. They're different, right? And so if I just put the exponent at the end, there could be some confusion about what that means. So basically what old guys a long time ago decided to start doing to clear that confusion was they started putting the exponent here to say that I am squaring the entire cosine function. What this means is it's the cosine of theta, and then take that whole thing and square it. You're going to square the entire cosine value. So when I plug in my theta equals 2 pi over 3, this is really telling me to find the cosine value of 2 pi over 3 and then square it, multiply it by itself. Okay, well, we just found the cosine of 2 pi over 3. It was negative 1/2. So I'm going to take negative 1/2 and I'm going to square it. What do you get when you do negative 1/2 times itself? You get a positive 1/4. That is the value of cosine squared of theta when theta is 2 pi over 3. Okay, now how about cosine of 2 theta? Well, there's a 2 in here. Is that the same thing as this? Because these both have a 2 and a cosine in them. So do these mean the same thing? No, they're not quite the same, right? The 2's in a different spot. The one in A said take 2 and multiply it by the cosine of your angle. But this one is actually saying take your angle and multiply it by 2 and then find the cosine of that. So I'm going to take 2 and multiply it by my 2 pi over 3, right? This says multiply the angle by 2 and then take the cosine. Okay, so if I take my angle and multiply it by 2, this is like 2 over 1. So when I multiply across, this means the cosine of 4 pi over 3. This is asking me for what the cosine of 4 pi over 3 is. Okay, so what's the cosine of 4 pi over 3? Well, we are going to come back up here to our handy dandy unit circle. We're going to find 4 pi over 3, which is a little bit bigger than 3 pi over 3. We're a little bit bigger than 1 pi, so we're down here. 4 pi over 3, and I want the cosine value of it, which is our x coordinate. The cosine value of 4 pi over 3 is negative 1/2. So the cosine value of 4 pi over 3 is -1/2. And notice that is different than -1. These two things give you different values. They don't mean the same thing. All right, I want you to try your hand at these next ones and figure out what this is asking you to do. So you can hit the pause button and work on that and come back to me when you're ready. All right, hopefully you had a chance to look at that. So this first one is saying, I want you to take the sine of whatever theta is divided by 2. This is saying take your angle and divide it by 2 and then find the sine of that. So we have to figure out what the sine of our angle, 3 pi over 2, divided by 2 is. Okay, so how do I take 3 pi over 2 and divide by 2? Well, technically this is dividing fractions, so I'm going to change flip. I'm going to keep the thing on top. I'm going to change the division to multiplication. I'm going to flip the bottom one. So this is asking me for the sine of 3 pi over 4. So you're going to go to your handy dandy unit circle to 3 pi over 4. You're going to look at the y value, and you will find that the sine of 3 pi over 4 is the square root of 2 over 2. I'm going to have you verify that for me because I'm running out of time. The second one, what's this asking you? It's telling you to square the entire sine function. So this wants you to find the sine of your angle and then square it. So we have to find the sine of our angle, 3 pi over 2, and then square that. If you go up to your handy dandy unit circle, 3 pi over 2 is one of our landmark points. It's right down here. 3 pi over 2, and I want the sine value of it. So you're looking at your y coordinate. That's -1. So I'm going to put that in here, and I'm going to take -1, and I'm going to square it. When you square -1, you get +1. And what's this last one telling us? That's telling us to multiply your angle by -1 and then take the sine of that. This wants you to do the sine of -3 pi over 2. So where's -3 pi over 2? Well, +3 pi over 2 is down here. A negatively rotating angle is going to flip everything upside down. You'll remember from our negatively rotating angles, -3 pi over 2 was up here. It's in the same spot as pi over 2. This is the ordered pair we're looking for. And we are looking for the sine of that angle. The sine of -3 pi over 2 is your y coordinate of 1. All right, y'all. That is module 6. So there's a lot of information here. I want you to get comfortable using your unit circle. I want you to work on this over the weekend. I want you to start practicing this and then bring any questions that you have on Tuesday. And we'll talk about how to memorize the unit circle, and I'm going to give you some resources to help with that. So first, right now, figure out how to use it and get comfortable with using a completed one. And then I'm going to have you take the time and the energy to start memorizing it. So have a lovely, safe weekend. I hope everybody stays safe out there, and I will see you next week on Tuesday. Have a good one, y'all.